Hello everyone, welcome to another Kinetic Tutoring episode. Today I'm going to begin teaching some AP stats. So let's begin. Alright, so the first question we're going to go over is buying music online. Young people are more likely than older folk to buy music online. Here are the percent of people in several age groups who bought music online in a recent year. And as you can see, we have our graph here. Explain why it is not correct to use a pie chart to display these data. So the reason is going to be that if we add up the percentages, 24 plus 21, 45 plus 20, 65, plus 16, we're going to get 81, plus 10, 91, plus 3, 94, plus 1, 95. So we get 95%. When we create a pie chart, you would want this entire circle to represent 100% of the population or whatever is being represented. However, we only have data points for 95% of the data, so therefore the pie chart would look something like this, with 5% being missing. Now, obviously we don't want that just doesn't look right. So we would not use a pie chart because we do not have 100% of the data. Now, make a bar graph. So essentially, a bar graph is just when we have an y-axis, an x-axis. Let me draw a neater x-axis. There we go. And on the x-axis, we have one variable, and on the other, we have another variable. In this case, I'm going to choose percentage to be on the y-axis. Percentage. And I'm going to choose age to be the other one. So as we can see here, we're going to have a bar for each of these points. So 1, 2, 3, 4, 5, 6, 7. We're going to have 7 bars. One here, 12 to 17. But since I made my bar graph kind of small, we'll determine different numbers for these. You wouldn't want to do this on an actual exam, but for the sake of conserving space, I'm just going to relate these ages here, 12 to 17, 18 to 24, with these letters. So we get A, B, C, D, E, F, G. And then we have our bought music online, right? So we can see that the top number we have is 24. So we're going to want to have 24 be somewhat up over here so that the bar graph looks fuller. For example, if we had our 24 here, all of the data points would be either at or below this line, and that would leave the majority of this bar graph space blank, and it's not as visually appealing. So let's make 25 here, 20, 15, 10, 5. All right, so now we have A is 24. We make a bar that goes almost up to 25. B, 21. It's going to be a bar that's just a little bit above 20. You're going to want to label these, so 5, 10, 15, 20, 25. And of course, you would want to use a straight edge or a ruler on an official exam. Since I'm using a digital pad to input this data, that makes it a little bit more difficult. But we're just going to, I'm only doing this to teach you the concept, but yeah, on an official exam, you would want to, use a straight edge, make sure all of your lines are straight. So C is going to be 20, just a tiny bit shorter than the last one. D is going to be 16, just a little bit above 15. 10, 3, and 1. Another thing you want to do is when we have age, we want to specify that is in years. You want to put your units. Percentage doesn't really have units. The unit of percentage is just percent. So as you can see, just put the percent symbol and you should be good to go. And the last thing is be sure to label your axes, which we have done, and title your graph. So you just want to say percent. I'm gonna write it up here, but this is the title. You would want it above the graph, and as you can see, I don't have any space directly above it. Percent of people who buy music online by age. And essentially all you need is in your title. You don't have to write it exactly like this, but essentially what you're trying to get across in your title is, here are my two variables, here are how they correlate to each other. That's it. So let's move on to our second problem. All right, so it says, where do the young live? Below is a stem plot right here of the percent of residents, age 25 to 34 in each of the 50 states. As in the stem plot for older residents, the stems are a whole percent and the leaves are tenths of a percent. This time, each stem has been split in two, with values having leaves 0 through 4 placed on one stem and values ending in 5 through 9 placed on another stem. So the other graph is not here, but essentially it's the same thing, but without the split stems. As you can see here, we have two 1-1s, two 11s, two 12s, two 13s instead of one of each. So the first question is just simply, why did we split stems? And the reason to this is just going to be because it makes the data easier to read, easier to look through, because here you're going to have 11.0 to 11.4, and here you're going to have 11.6 to 11.9. So if you're looking for something in the lower 11s, you know where to look. Same thing for the upper 11s, and there's just not that much data compacted in one area. And as you can see, the more points on this axis lead to a better understanding of the distribution. As you can see, we have a nice little curve that would be very much less visible with only 6 points. All right. Give an appropriate key for the stem plot. So as it says here, so this is a key term, percentage out of 100%, and additionally, this just points us in the right direction, because we know how this works is you take these two terms and then you add the last one, so it's 114. So and then the next term would be 114 again, and then we have 116, 116, 117, 117, 118. And we can tell it's not going to be 114%, because percent only goes up to 100% when we're talking in terms of a certain demographic in a population. So, and as we read further, it says the stems right here on the left side are whole percent, and the leaves on the right side are tenths of a percent. So that tells us to put our decimal point here. So here's what it looks like originally. 11 line 4 is equal to 11.4 units. What is a unit? Percentage. So here is an appropriate key for the stem plot. Describe the shape, center and spread of the distribution. All right, so if we take a look here, it looks like there are more numbers to the right side, just slightly more, as we can see. Or let's say, okay, let's call this, if we say 11, 12, 13, 14, 15, 16. There's 7 points in 11. In 12 we have 13. In 13 we have 13 plus however many that is. That's going to be 7. So we have 20. 14 gives us 7 values. 15 gives us only 2 values. And 16 gives us 0 value, or gives us 1 value rather. All right. So as you can see, it's a little bit more left heavy. There are more values given on the left than there are on the right. So that means that the shape of this, as we can see here, you could kind of tell, but it was kind of hard to tell, so I wrote it out. There's going to be more values on the left, so it's going to be skewed right. So that's the shape. The center is just going to be the median, which you can find by adding up all these values and then dividing by the combined number of values. So you'd go 11.4 plus 11.4 plus 11.6 all the way up to plus 16. And you would find the median there. And that's just a simple calculator problem. You will be given a calculator on the AP exam. And finally, are there any outliers? Just using the eye test because it doesn't cover the outlier formula in Unit 1. Yeah, there is an outlier at 16.0 because as you can see, it's kind of far from the other data. It just doesn't fit in, so 16.0 is going to be our outlier. Let's move on to the next problem. Here are the scores on the survey of study habits for 18 first-year college women. So here are these women's scores on their SSHA exams, and we have the same exam taken by 20 first-year college men, and here are their scores. And do these data support the belief that women have better study habits than men? High scores indicate good study habits. So you would just take the average of both. So for example, you would add all of these up and then divide by 18 to get the average study SSHA for women. Same thing here, add all these up, divide by 20 to find the average SSHA, find which one is higher. So I'm going to do this one just so you guys can compare answers. All right, 154 plus 109 plus 137 plus 115 plus 152 plus 140 plus 132. Oh, there's no 130 there. Plus 152 plus 140 plus 154 plus 178 plus 101 plus 103 plus 126 plus 137 plus 165 plus 129 plus 200 plus 148. All right, and then we're going to divide this value, which is 2,248, by 18. We get that they get an average SSHA of 124.9, rounding to the 10th place. Let's do it for the 20 men. Plus 140, plus 114, plus 91, plus 180, plus 115, plus 126, plus 92, plus 169, plus 146, 109 plus 132 plus 75 plus 88 plus 113 plus 151 plus 70 plus 115 plus 187 plus 104. All right, 2,425. Divide this by 20, and we'll get 121.25, or rounding to the 10th place, 121.3. As you can see, the women's score is going to be higher. Do these data support that women have a better study habit? Well, as we can see, they have the higher scores, so yes, it does support it. And it wants us to follow the 4-step process, which is, as we saw from the last problem, I'm just going to go back. We have shape, center, and spread. So you can plot out all these points, find how spread out they are, meaning the maximum value minus the minimum value. That shows how varied they are. And then there's the center, which in this case we use the average, also known as the mean. The shape, how it's skewed left or right, that doesn't really affect the outcome too much. That just shows a general pattern. And outliers, in some cases you would take the outliers out, but in this case I don't think there's any spectacularly, insane outliers that would be taken out. They all seem somewhat in the same space. The 70 and 75 seem a little low, but not too low to where we wouldn't count them as part of the data. So yes, it does support the belief, because the average intelligence of the women in the study, or not intelligence, average survey of study habits and attitude score of the women in the study turns out to be 3.6 scores higher than for the men, meaning that they have better study scores, study habits, and attitudes. So there you have it. That's my Chapter 1 review. If you have any questions, comments, or concerns, leave them down in the comment section below. If you thought this video was helpful, make sure to leave a like and subscribe, and I'll see you guys next time.